Let's take a look at exercise 6.2.35. We have information about 3 foods, the nutritional content per ounce for vitamins A, iron, and calcium. And a diet must consist precisely of 264 units of vitamin A, 216 units of iron, and 408 units of calcium. However, the dietitian runs out of food. 1. Use a matrix approach to show that under these conditions, the dietary requirements cannot be met. We're going to let X equal the ounces of food 1. This is the food that the dietitian runs out with for part A. We're going to let Y equal the ounces of food 2 and Z equal the ounces of food 3. And we're going to set up a system of equations for part A. So 36xy, because we don't have food 1, 36y plus 12z units of vitamin A must equal 264. So let's look at the units of iron. 12y units of iron plus 12z units of iron have to equal the 216 units of iron that are needed. 12y units of calcium plus 36z units of calcium have to equal the 408 units of calcium that are needed. So in column 1, we put the coefficients of Y of our augmented matrix. In column 2, we put the coefficients of Z. We write our dividing vertical line, and in the third column, we put our constants that are on the opposite side of the equation from the variable terms. Now let's make these coefficients smaller by multiplying each equation by 1/12, since that will make our coefficient smaller, and at the same time we will avoid fractions. So you don't want to make your coefficient smaller if even one of them is going to turn into a fraction at this stage of your work. Alright, so this is an equivalent matrix that we're going to work with to represent our system. We're going to get our zeros in column 1. So notice we have more equations than we have variables. So our anchor row, when we're getting our zeros in column 1, is row 1. So we're going to recopy that and leave it unchanged. And we are going to multiply -3 times row 2 and add that to row 1. And doing that, -3 times 1 plus 3 is 0. -3 times 1 plus 1 is -2. -3 times 18 plus 22 is -32. That gives us our row 2. And now our new row 3 is R1 minus 3 times row 3. And that gives us 0, -8, and -80. So now let's get our zeros in column 2. Those will be in rows 1 and 3. And when we're getting our zeros in column 2, row 2 is our anchor row. So we recopy that anchor row, and we're going to change row 1 as we get our zeros in column 2 by multiplying 2 times row 1 and adding that to row 2. We're going to multiply -4 by row 2 and add that to row 3 to get our new row 3. So 0 plus 2 times 3 is 6. -2 plus 2 times 1 is 0. -32 plus 2 times 22 is 12. Now let's get our row 3. -4 times 0 plus 0 is 0. -4 times -2 plus -8 is 0. And then I get a 48 in the third column of row 3. And notice that row 3 tells me 0 equals 48, which is false. So the system is inconsistent. The solution set is the empty set. Now, what does that mean with respect to this application that we're doing? This basically tells us the fact that there aren't any solutions tells us there's no way to satisfy the nutritional requirements using only foods 2 and 3. So that's an important understanding to have when you're working an application. What does the result actually mean for the application? Now, if I take this all the way down to reduced echelon form by getting my 1s on my diagonal elements, I divided row 1 by 6, row 2 by -2, and row 3 by 48. Notice that that's still an inconsistent system, but that's actually the reduced echelon form. That's equivalent to any matrix representing an inconsistent system with 3 equations and 2 unknowns. So the matrix on the right is the matrix that was in the choice for the reduced form of the matrix in my math lab. You actually can't get that form, but the 2 matrices are equivalent because they represent a system with 2 unknowns and 3 equations that's inconsistent. So they're actually equivalent to each other. All right, in part B, I want to suppose all 3 foods are available, and I want to use matrices to give a possible way to meet the iron and calcium requirements with the 3 foods. Alright, so I'm still going to let X be the ounces of food 1, Y the ounces of food 2, and Z the ounces of food 3. So 24X units of vitamin A, no, we're doing iron and calcium, of iron plus 12Y units of iron plus 12Z units of iron have to equal the 216 units of iron. 12X units of calcium plus 12Y units of calcium plus 36Z units of calcium have to equal the 408 units of calcium needed. So now I have 3 variables and only 2 equations. Here's my augmented matrix that represents this system. Again, I'm going to divide each equation by 12 to make my coefficients smaller, which I always want to do if possible, but I do want to avoid fractions. So the first row is 21118, the second row 11334 when I divide each component by 12. So I'm going to get my zeros in column 1, and my anchor row is row 1. So row 1 minus 2 row 2 gives me a row 2 of 0, -1, -5, and -50. Now let's get our zeros in column 2, which means row 2 is our anchor row, and we're going to add row 2 and row 1 to obtain that, and we're going to copy our anchor row 2. So 2 plus 0 is 2, 1 plus -1 is 0, 1 plus -5 is -4, 18 minus 50 is -32. So those are all the zeros that I need. Now I simply need to get my ones on the diagonal. I multiply row 1 by 1/2, row 2 by -1, and my row 1 is 1, 0, -2, -16. Row 2 is 0, 1, 5, 50. So this is my reduced echelon matrix, and it tells me x minus 2z is -16. That means x is 2z minus 16. Y plus 5z is equal to 50, tells me y equals 50 minus 5z. So these two equations come from the two rows of the reduced echelon matrix. So I want to find a possible way to meet the nutritional requirements for iron and calcium. But here's what I need. I need x to be bigger than 0, y to be bigger than 0, and z to be bigger than 0. So I need all three of these things to be true. Since x is 2z minus 16, that needs to be bigger than 0. Y is 50 minus 5z, that needs to be 0. And of course, z needs to be 0. So when I simplify these inequalities, z needs to be bigger than 8 and 10 needs to be bigger than z, which is the same as z needs to be less than 10. So z essentially needs to be positive and lie between 8 and 10. So if you lie between 8 and 10, you are positive. The only integer value between 8 and 10 is 9. So there are infinitely many values between 8 and 10, but only one of them is an integer. So there are many ways to satisfy this, where the number of ounces of the third food is not an integer value. So if we let z equal 9, x is 2 and y is 5. So a workable combination is 2 ounces of food 1, 5 ounces of food 2, and 9 ounces of food 3. And so in the My Math Lab problem, you will actually have you'll have 4 choices to choose from, and this would be one of the choices, where you have 2 ounces of food 1, 5 ounces of food 2, and 9 ounces of food 3. So this is an example of what an application looks like when you have a situation where you have more variables than equations.